So, for a long time now, our conversation about AI and software development has really centered on one idea.
The coding assistant.
Exactly, that helpful sidekick, maybe a GitHub Copilot. It's generating snippets, suggesting improvements, fixing a single bug.
They're partners in your IDE, sure, but the human is always, always at the wheel.
And that paradigm is dramatically shifting.
Oh, it is.
Yeah.
Today, we are deep diving into the source material for something called Ralph-Claude-Code, which is just a major conceptual leap.
It's the autonomous AI developer loop.
Right. This isn't an assistant. It's an agent. It's designed to take initial requirements and then just run. It runs continuous self-correcting cycles and iteratively develops a whole project until it decides it's done.
Okay, let's unpack that because, the shift from assistant to autonomous agent, that introduces huge new risks. The first fear, the instant one, is what if it never stops? Or maybe more practically, what if it bankrupts me on API calls before it writes a single working line of code?
And that is the perfect place to start. The creators of Ralph, they understood that the core challenge of autonomy isn't even generating the code.
Claude-Code already does that brilliantly.
It does. The real challenge is managing the process. Ralph is an implementation of a known architectural approach. People often call it the Ralph Wiggum technique.
Ah, okay, I remember that name. For anyone who doesn't know the reference, Ralph Wiggum from The Simpsons. He's the kid who is delightfully simple.
Yeah.
He's often repeating things, moving in loops, but sometimes just by sheer repetition, he stumbles onto something brilliant.
Exactly. And the technique leverages that simple iterative cycle. Read, act, check, repeat. That's it. But what the creators of Ralph have done is wrap that simple loop in some really sophisticated professional-grade engineering.
To address those two fears I mentioned.
They hit them head-on with intelligent exit detection and strict rate limiting. This transforms what could be an infinite, expensive process into something reliable, managed, and, financially constrained.
That distinction right there, manage versus infinite, that's everything. And this isn't just theoretical, right? This is live. It's in active development.
It's absolutely live. According to the source material, the current version is v0.9.8. So all the core features are there. They're just being refined.
And they have a timeline.
A very clear public timeline. They're aiming for v1.0, which they're calling the stable production release, in about 4 weeks. And it's designed as a one-time global command. You install it once, and then you can just use the Ralph command in any project on your system.
So once it's installed, the workflow is just define the task and let the cycle begin. So let's get into the heart of the system. What are the simple, powerful steps that make up this loop?
The beauty is really in its simplicity. That's what makes it so robust. It's this foundational cycle that just runs until one of those engineered exit conditions is met.
And it's a 5-step process.
A 5-step continuous process. Step 1, read instructions. Ralph loads the main project goal from the primary requirements file, which is ppron.ptt.md. Step 2, execute Claude-Code. It calls the AI, feeds it the current context, the history, the task list, and basically asks, okay, what's next?
So it's constantly deciding the next action based on what happened just before.
Precisely, which leads to step 3, track progress. The output from the AI gets logged, and the internal task lists are updated, specifically this one control file at fixplan.md.
And that's where it keeps its own notes, basically.
Yeah, did it pass tests? Did it fix a bug? Did it complete a subtask? Then step 4 is evaluate completion. Ralph checks for those intelligent exit conditions. Are all tasks done? Is it looping aimlessly? Has it hit a limit?
And if the answer is no,
Then step 5, repeat. The loop continues.
I appreciate how it's self-organizing. It forces the human developer to define clear boundaries through these mandatory files.
It has to. An autonomous agent needs designed rails to run on. If you just give an AI a vague goal, you're going to get chaos.
So beyond that main instruction in promipt.md and the task list at fixplan.md, what other structure does it impose?
It creates a standardized project structure that the AI can actually navigate. It separates concerns. So you have a specs directory that holds detailed requirements, and then you have SRC, which is only for the implementation code.
So the AI always knows where to look for the rules and where to put its work.
Exactly. It moves the focus from how to code to what to code next based on those structured requirements.
Which brings us right back to those critical engineering challenges, the safeguards. If I'm handing over the keys, I need to know my wallet is safe and the AI won't get stuck in some endless loop. Let's start with the money.
Financial control is the first line of defense. They use explicit rate limiting. By default, Ralph caps itself at 100 first. Claude-Code API calls an hour.
That's the default.
It is. And it's adjustable with a simple calls flag, but that default gives you a huge buffer against accidental costs. It turns the risk of running for a week into a manageable hour-by-hour budget.
I see the immediate benefit there. Even if it gets stuck, you know your burn rate is capped. Now, what about the intellectual safety net, the intelligent exit detection? This part fascinates me.
It's necessary redundancy. Ralph is designed to self-terminate successfully. The most straightforward check is, when all the tasks in that at fixedplan.md file are marked complete.
But it adds more layers.
2 more layers of independent verification.
What was the first one?
The first one is that the AI has to explicitly confirm it's done. Ralph will only stop after it detects multiple consecutive done signals from Claude code. The source sets this at 2 signals.
So it's like, I think I'm done. Are you sure? Yes, I'm sure.
Exactly. It prevents a premature exit based on just one, maybe erroneous, signal.
That makes a lot of sense, like needing a second opinion before you merge a pull request. What's the second, more subtle layer?
This one shows real development maturity. Ralph exits if it detects too many consecutive loops that are just focused on testing or refactoring, polishing the code, not adding new features.
And what's the limit on that?
They've capped this refinement phase at 3 test-focused loops. It's controlled by a setting, max consecutive at test loops 3.
Why cap testing? I mean, why not let it try to achieve perfection?
Because that kind of unbounded polishing is often a sign of diminishing returns, or the AI is just getting stuck on tiny details that don't add business value.
A human engineer knows when to stop optimizing and ship it.
Right. So this limit prevents Ralph from spending hours trying to find some tiny improvement when the main features are already done and tested. It's an efficiency threshold, really.
Wow, okay, but what if it hits a real bug? Not a refinement issue, but it starts repeating the same error cycle over and over. It's working, but it's making zero progress and just burning through API calls.
And that's where the ultimate failsafe comes in, the circuit breaker.
Right.
This is crucial for preventing genuine runaway loops. And what's fascinating is that the error detection here, it's not just a simple search for the word error, it uses advanced detection, 2-stage filtering, multi-line error matching.
So it can spot repeated stagnation, not just a one-off compilation error.
That's the key. It's looking for a pattern of stagnation.
How sensitive is that trigger, though? If it sees no progress, why wait for 3 or 5 loops? Isn't that still wasting a few calls?
That's a great question. It's a balance. If you stop the loop too early, you prevent the AI from using its own self-correction abilities.
Ah, I see.
So Ralph is calibrated to wait just long enough to confirm a genuine pattern. The circuit opens if it detects either 3 loops with 0 progress, no file changes at all, or 5 loops where the same underlying error messages pop up again and again.
And once that circuit opens, it's not letting it immediately try again?
No way.
Yeah.
The system enters a gradual recovery mode. It's called a half-open monitoring state. It basically gives the AI a cooldown period and forces a context reset before it even attempts to run again.
That is some professional engineering.
It really is. It's applied to a highly volatile process.
I also noticed the source material talks about how Ralph handles a very specific real-world limit of the Claude API, the 5-hour usage limit. That feels like the mark of a mature tool.
It's a brilliant practical piece of engineering. A lot of other agents would just crash or retry endlessly for 5 hours, costing you time and locking things up.
So what does Ralph do?
It detects that specific API error. And instead of failing, it gracefully prompts you, the user, with 2 clear options. You can either wait the 60 minutes for the limit to reset, and it even gives you a countdown timer, or you can just exit gracefully.
No endless, pointless retries.
Exactly. It respects your time.
That attention to detail is what elevates this from a cool proof of concept to a dependable tool. Let's shift to setup. You mentioned a 2-phase initialization.
Right. Phase 1 is the standard one-time global install. You just run.install.esh. That sets up the main Ralph command.
And phase 2?
That's per project. For a brand new project, use Ralph setup to create the structure. But the real game changer, especially for existing code bases, is the Ralph import command.
The Ralph import command. This is where the AI really starts to feel like a systems analyst, not just a coder.
Absolutely. Think about that common problem. You have a massive product requirement document or some huge legacy spec, and your first job is just to translate that into a structured task list.
Ralph import automates that translation.
It does. It lets Ralph convert almost any existing requirement document into the structured project files that the autonomous loop needs to get started.
What kind of formats can you throw at it? Are we just talking about, like, text files?
No, it's incredibly versatile. It supports standard text and Markdown, JSON, of course. But the crucial part, is it also handles proprietary formats, like Word documents and even scanned PDFs.
PDFs? Seriously?
Yes, essentially any text-based requirement document you have can be processed. An organization can leverage years of existing documentation almost instantly.
Okay, so if I throw a 50-page PDF at it, what comes out on the other side?
The output is that mandatory control structure we talked about. The original content gets converted and summarized into the main goal in prompt PEMD. Then the technical specs are extracted and organized into specs-requirements.md.
And most importantly,
the key steps and priorities are broken down into an actionable sequence list in that fixplan.md file. That's the process that turns a static document into a dynamic development plan for the AI.
speaking of being actionable, the tech sophistication in the latest update, v0.9.8, seems really focused on reliable communication between Ralph and Claude.
They seem obsessed with avoiding brittle connections. And for good reason.
Right.
The v0.9.8 update introduced mandatory JSON output format usage for communication. Historically, these tools would rely on parsing messy, unstructured text output from the model.
Which breaks the second the model changes its phrasing a tiny bit.
Constantly. By forcing the use of the modern Claude-Code CLI JSON format, they ensure structured, reliable parsing. It makes the whole process infinitely more robust.
And if someone's on an older version of the CLI, does it break?
No, and that's the smart part. That robustness extends to backward compatibility. There's an automatic fallback. If it doesn't detect the JSON output, it just reverts to standard text parsing. It ensures the process keeps working.
That kind of flexibility is key for real-world adoption. I want to circle back to session continuity. We talked about Ralph getting stuck, but when it's working well, why is it so important for the AI to remember its recent history?
Memory is context, and context is efficiency. The continue flag is used to maintain that context across loops. Without it, the AI would have to reread and reprocess the entire project history every single time.
Which would lead to huge token waste.
And disjointed logic. Ralph maintains a detailed history of the last 50 transitions in a file called .ralph session. So when a new loop starts, it knows exactly where it left off.
And when does that memory get wiped? Because you wouldn't want it to remember a bad path if it goes off the rails.
Right. That's why there are explicit auto-reset triggers. The session automatically resets if the circuit breaker opens. That means catastrophic failure, time for a fresh start. It also resets on a manual interrupt or, of course, unsuccessful project completion.
It prevents a poisoned context from damaging future work.
Exactly.
So we have this powerful, managed, financially constrained agent running. For the human developer who launched it, how do they monitor the work without just, tailing a giant log file?
That's the utility of the integrated monitoring. The recommended way is the Tatmux integration. You just run Ralph Monitor.
Tatmux.
So for anyone who lives in the terminal, that's going to feel right at home.
It's a great choice because it's designed for persistent background processes that you can detach and reattach safely.
So what does that dashboard actually show you?
It gives you a concise live dashboard. You see the current loop count, which is crucial for monitoring pace. You get a real-time status of API calls used versus your hourly limit.
So you know your budget utilization.
Exactly. And it gives you a rolling log of recent activities. You can start Ralph, launch the monitor, detach the session, go grab a coffee, and come back hours later to see the progress.
That provides some serious peace of mind. But let's talk about the backbone of all this, stability. If an agent is making automated decisions, we need to know its core systems are reliable. What does the testing status tell us?
The documentation is very explicit about this, and it's inspiring. Ralph currently has 276 tests across 11 files.
And the pass rate? 100% pass rate. And this isn't a vanity metric. Achieving that kind of coverage in a shell-based autonomous loop, which is what Ralph primarily is really challenging. These aren't just simple unit tests. They cover integration scenarios.
Like the full loop execution.
The full loop, importing a complex requirements document, the whole environment setup. That level of comprehensive passing integration tests is what lets you truly trust the autonomous workflow.
Okay, so if you're monitoring the system and you suspect it's stuck, maybe the loop count is rising but no files are changing, what are the immediate debugging steps the source recommends?
The advice directs you right back to the human element. The first step is always to review at fixplan.md. Stuck loops are often caused by unclear or conflicting tasks that the human provided in the first place.
The AI struggles with ambiguity.
Always. Now, if the task is just computationally complex, you can increase the execution timeout. It defaults to 15 minutes, but you can change that with timeout MIM. Or you can just run Ralph status to get a clean JSON status output.
This whole deep dive makes it so clear that Ralph isn't just a command line wrapper. It's a highly engineered execution environment.
That's the perfect way to put it. It's designed to make autonomy safe, efficient, and reliable. It takes an extremely powerful AI coding engine, Claude-Code, and wraps it in this robust, managed engineering shell.
It shifts the entire definition of development.
It does. You're no longer responsible for writing the code, but you are absolutely responsible for writing extremely clear, well-structured, and bounded requirements and specifications.
That's the real takeaway here. It's a profound shift in our professional identity. The best practices section of the source hammers this home, the need for specific, prioritized, boundary set prompts. If the AI can reliably handle implementation, debugging, continuous integration, all these execution details, then the hardest task for the human developer is no longer implementation. It's achieving total clarity and precision in defining that initial prom.mpt.md and at fixplan.md.
It completely inverts the hierarchy of effort. For decades, developers spent, 80% of their time on execution and 20% on planning. Now, the AI handles the execution, which demands that the human achieve 100% precision in planning.
We're moving from being coders to being architects of perfect requirements.
Exactly.
And what does that demand from human creativity? It demands that we become hyper-efficient at specification, at translating these abstract goals into concrete, structured, achievable steps for a machine that, while brilliant, has zero imagination.
We have to anticipate every edge case, every ambiguity, every constraint before that first loop even runs.
That capacity for perfect, structured foresight might just be the most valuable and the most challenging human skill left in the age of autonomous agents.
That is a stunning thought. If the AI becomes the perfect hands, the human must evolve into the perfect, utterly precise brain.
A powerful shift worth contemplating as you define your next project requirements.